I think it is clear that in order to solve a question like this one, you need to familiarize yourself first with what a homogeneous system of linear equations is. Simply, a homogeneous system of linear equations is one that looks like this. So you have some matrix, you have some vector, and you're looking for the homogeneous solution. Homogeneous means that the system or the vector of variables in the end is the zero vector. Okay. Let's take a look at some interesting statements in no particular order. Yes. And so I would like to, for example, consider this one. So this says if A is a solution, then there exists a K multiple or a scaling such that Ka is not a solution. Well, let's see. What does it mean for A to be a solution? Let's investigate this. So directly from the definition of A as a solution, then A solves this equation. So I can replace this X with that A. Okay, that's amazing, right? Okay, now there is a claim that if I scale this A by some constant, my equation will become non-zero somehow. And this doesn't really hold any truth to it. Because if we take a look at, for example, A, and let's say we scale it by some constant K, then we have a copy. We have a scaling of the vector. We scale the vector and then we apply the matrix. Remember, the matrix is what? It's a map, and it's a linear map. A matrix is a linear map. This is very, very, very important. And if the matrix is a linear map, then by linearity, I can take the constant outside. So, in other words, I can apply the matrix first to A and then scale whatever the result is going to be by K. This is precisely what I mean. This is one property of the matrix. The matrix is a linear map, and because it's a linear map, I can take constants outside before applying the map, and I could also, maybe we'll save that for a couple of minutes later. And now, okay, so if this is true, then this is true because you're scaling this vector, which is the zero vector, by some K, you always get this zero vector. So there is not a K such that Ka is not a solution. It's a double negation statement. So any K you place as a multiple of A will give you another solution. So you get a full family of solutions just by scaling A. So this is not true. There is no such K that could make our solution or make our Ka not be equal to the zero vector. And now going back to the property, the other property that I was hinting at, I would like to consider first choice A. So what does choice A tell us? Yeah, this is great. So it says that if A and B are two different solutions, well, two solutions in general, then A plus B is a solution. Well, let's see what it means for A to be a solution and for B to be a solution. So the direct consequence of this, I'm not sure about this one, but I can say that the direct consequence of A and B being solutions, it means that If I apply the matrix A to the vector A, I'll get 0. If I apply it to the vector B, I'll also get 0. This is 100% correct. I can confidently vouch for this. Now consider this expression. If this is a solution, then when I apply the matrix A to A plus B, I should get 0. I don't know just yet. That's why I put a question mark. Is this going to be the case or not? So this statement, if this statement is true, then it just means by definition that A plus B is a solution and we're done. Now, is this the case? And I claim that this is indeed the case. You need to use the linearity of the matrix. The matrix is a linear map. And linearity means that I can apply the matrix to each vector separately, and it would have the same effect as applying it to the sum. So the sum of the matrix, the sum of applying the matrix is equal to applying the matrix to the sum. It's a bit tongue twisting. That's why I was struggling to say it. But anyway, A is linear. It's a linear system of equations. And if it's a linear system of equations, then I can write AA plus AB. And to my good fortune, this is by assumption equal to the 0 vector. This is by assumption equal to the 0 vector. So it is indeed true that if I add the 0 vector to the 0 vector, I'll get the 0 vector. And so it is indeed true that A plus B should be solutions. So the idea really here is to grasp the concept of linearity of the matrix. That's number one. And number two, you need to familiarize yourself with what a homogeneous system of equations is. It's the system to which its solutions, you're solving AX is equal to 0. It's something like, no, I don't want to say this. It's not like anything. So these are the two facts that you need to know. And otherwise, it doesn't seem like there's anything else. So A is the solution to the exercise.